All right then. So, welcome everybody. Welcome to my talk. Thank you so much for attending. My name is Sarjeel Yusuf, and this is the first time I'm speaking at NDC, and I'm really glad to be here, guys. I'm from Atlassian, but not based in Australia. I'm actually based in the Turkish office. A lot of people didn't know that, right? Yes, Atlassian does have an office in Ankara, Turkey. It was a long flight here, so thank you so much for having me, guys. My talk is about cold starts in the .NET environment. Just a bit of a warning: I'm not a .NET expert, right? So, but my passion does lie in the cloud, especially in serverless technologies. I started off my career in serverless monitoring, and that's where I realized that we have a huge deficiency for at least the .NET platform when it comes to serverless functions, right? And that was the motivation for me to come up with this talk, right? And going through the agenda, we'll go through just a quick show of hands. How many of you guys are building in serverless or any serverless functions, lambda, Azure? Hey, all right, that's good, right? Most of the room. How many of you guys use AWS Lambda? All right, it's like, and Azure functions? All right, that's pretty cool, yeah. So again, just a quick preview. Most of this talk is towards AWS Lambda because OpsGenie, the tool, a tool in Atlassian where I work, is built fully on an AWS stack, but the talk will cover both Azure functions and AWS Lambda, but it's slightly oriented towards AWS Lambda. Not because AWS Lambda is better for .NET functions as compared to Azure. That's a whole other debate that we can have later on, right? It's just out of pure experience and pure practical experience that I've had, right? So and that's what I want to present to you guys, the practical experience that I've had. So we'll start with like what cold starts are. Where do cold starts actually originate from? We all have some vague idea of what a cold start is, but let's actually go into the depth of where it actually comes from, why it is actually an inherent problem of serverless functions. We'll dive deep into the problems associated specifically with .NET functions. We'll go through the solutions specifically tailored for .NET functions. Again, I mean, there are a lot of solutions, and there's a lot of discussion about how to reduce cold starts and stuff like that. But let's look at the ones specifically for .NET functions, because .NET itself is a very unique runtime as compared to the other, conventional runtimes used in serverless functions. And we'll also look at where we stand right now, and what we can expect in the future, right? So, I mean, why are we here? Why did I have to come, take a 15-hour flight just to come here and tell you guys about, cold start problems for .NET functions in serverless? Well, the truth is that, serverless is the hot word right now. It's the buzzword right now, and it's rising in popularity, right? So, for example, let me just see if I can get my speaker notes up here. Yeah. So, we see a rise in serverless over the few years, and according to the RightScale 2018 State of Cloud report, we see a 75% growth rate in the usage of serverless. So we see serverless on the rise, and the major reason why serverless has become such a buzzword is because the promises that it's offering, and we are probably all aware of this. Abstract away huge parts of your underlying architecture and give that responsibility to the cloud vendor. Get up and running with your business logic immediately. You no longer have to worry about the traditional problems that containers had, and now you have this container versus serverless wars going on. Where serverless is saying, oh, you don't need to worry about container orchestration or networking, and all of that is now being managed by your cloud vendor, and all you need to worry about is the business logic. And this is great for startups, especially startups. This is great for large enterprises because now we don't need to invest so much resources, so much engineering effort into our into building our infrastructure, our supporting infrastructure for our, business logic, right? And what this helps us is it helps us become agile. When we talk about agility, we often talk about, how quickly we can get from the point that an idea is conceived to its release and getting that idea into the hands of the user, right? So what we see is with serverless, especially with lambda functions, Azure functions, we see great benefits such as auto scaling. You no longer have to worry about scalability. If you have high traffic, it scales to high traffic. If you have nobody coming to your site or nobody using your product, you don't have to pay for the resources over there. So that's the pay-as-you-go model. That's another great feature of serverless. That's something that really entices startups to take up the technology. We have, again, as I mentioned before, it's just easy to set up and easy to use. And for example, I graduated very recently from university just last year, and I joined a company and they threw a lambda function at me, and I just got up and running with the lambda function. It wasn't that difficult. When I started using containers, there was a steep learning curve for me to get over. Especially when you start talking about Kubernetes, that's a really lean, steep learning curve, right? So it's not. So that's one of the great advantages, right? And also because it's the pay-as-you-go model allows us to be flexible in the way we can, acquire these resources. So we can use a lambda function or an Azure function and use it for testing to test out how our idea is received in the market. If you don't like it, simply tear it down, rewrite your business logic and then put it up again. So it really allows us to iterate much quicker, right? And that really does promote agility. So it lets you to experiment more. There's more experimentation now, right? As compared to like setting, provisioning a container, having to tear it down, paying for that container. It was a bad idea. Oh my God, we fell flat on our faces. We have to do it all over again, right? And this is exactly what I'm talking about. You have your infrastructure as a service, which is generally your EC2 instances, your containers in general, right? And you have to manage, everything associated to your container. You have to, yes, you have all of your operating system and your virtualization and your hardware. All of that responsibility has been abstracted away to the vendor. That's great. That we started seeing these benefits of moving to the cloud, and there's been a lot of talk about, what the cloud provides, right? But then we wanted more. We were greedy. And so we came up with containers as a service, and AWS Fargate is one of the more recent services in the cloud ecosystem, which allows you to get up and running with containers, right? So you already have your networking set up. For example, AWS Fargate comes with already set up ENI networking capabilities. And then then at the end of the spectrum, you have your function as a service, which is your traditional serverless functions, your AWS Lambda, your functions, and that has most of the responsibilities abstracted away. So you just focus on your application, your functions, up and running. There you go. And what that means is that it's it's not your job anymore. You can literally just say, oh, that's not my job. I don't need to worry about this shit. I'm done. I got my code up and running. I'm done. So that's basically the motivation over here. People are moving towards things that are easier. People are obviously going to take up things that are easier, and Lambda functions and Azure functions and serverless Google Cloud functions is this easier option, right? But it's not the same for everybody. We have also discussed about the limitations that the serverless environment has, right? And one of these limitations is cold starts, what we're all here to talk about, right? And so just a quick story. In my first job, I was working in a company called Thunder.io before I joined Atlassian, and we were doing serverless monitoring. And one of my tasks over there was to create the .NET agent. I was working with a brilliant engineer called Ibrahim back in the office, and what we noticed was when we were building our .NET agent and we were monitoring our when we started the initial prototypes of our .NET agent trying to monitor .NET functions, we saw that cold starts in the .NET environment were much higher than we perceived, than we were used to. And we were wondering, like, is our .NET agent, is the .NET agent that we built faulty? Are we measuring cold starts wrong? And I dug a little into this, and I came across a great great piece by Mikhail Shilkov, who traditionally looks into cold starts in the serverless world. And what we found thanks to Shilkov's results was that .NET or C# functions in general have tremendously high cold start cold start durations. And this isn't only in AWS Lambda, but across almost all cloud vendors, right? So in Shilkov's results, we saw even with Azure and AWS, we saw that we have really high cold starts, right? And when you think of it like, oh, maybe it's because it's a static language. No, well, for Java, you don't have that problem. That's what we see, right? So Shilkov's really got me thinking, like, why is this so? What is the problem over here, and why aren't we addressing this? Why isn't the community addressing this? And that was the motivation for this talk. The motivation was, is serverless for .NET, right? Can we use serverless technologies for .NET? I mean, we've talked about the benefits of serverless, but can the .NET community now, benefit from these advantages that serverless brings, right? And because if the world is moving towards serverless, right? I mean, yes, that is also up for debate, containers versus serverless. But let's say if the world is moving towards serverless, is the .NET community going to be left out, right? And serverless functions, and the way we need to think of this is like, why aren't people looking into this? And the major reason is because .NET is just not one of the more popular languages when building your serverless applications. According to a report done by the Serverless Framework in 2018, we saw that 70% of services deployed were built in Node.js. And the reason for this is that when you think of serverless applications, you mostly think of asynchronous operations. And when you think of asynchronous operations, you mostly think of Node.js, even though you can achieve asynchronous tasks in all languages, right? But you mostly think of Node.js, right? And that's why you would see like almost above 70% of services being built in Node.js, and that is common knowledge. I mean, like we all knew this. The reason why I put this statistic up is so that we know the exact statistic and we can prove that yes, what we believe that Node.js is the most common language for serverless applications is true, and this is the statistic, right? And but can we expect other languages to come up? Well, at the moment, when we're talking about .NET Core, not really. We still see that .NET Core is trailing behind, right? We see that Python 3.6 is one of the fastest growing languages when it comes in popularity, but .NET for .NET Core, unfortunately, we can't say the same thing, right? How many of you guys work in .NET? I'm guessing almost all of you, because you all came to this talk, right? Right? So yeah, so this is this is something that we should be concerned about. Can we start working with serverless functions when they finally do improve and when they finally do become mainstream, right? So let's talk about the problem over here. Let's talk about what the cold start is, and where does it originate from? Well, to know that, let's talk about the value of serverless. So in the beginning, I said that the concept of serverless is the pay-as-you-go model, which is based on you have resources provisioned to you, you have resources allocated to you when you need them. When you don't need them, they're no longer allocated to you, and therefore you don't need to pay for them, right? So how does that work? How do we get that? It's due to ephemeral containers. So what does that mean? Like in the case of AWS Lambda specifically, so AWS Lambda and even Fargate, AWS Fargate are built on a technology called Firecracker. Any of you guys have heard of Firecracker before? Yeah? One guy? That's cool. I'm going to talk to you after this talk. Yeah. So it's built on Firecracker, and the way it works is that when, just the gist of it is that Firecracker provisions your containers when you need it and tears them down when you don't need them, right? But what that means is that if you're not using them, they're going to stay for a while, and then they're going to get torn down and allocated to somebody else who's using them. And that's the inherent problem, right? So when you do need them again, right, your container needs to start up again. And that's where the cold start originates from. So your container needs to start up again, and your container starting up means that, so this is a slide from an AWS talk, where we're defining what the container startup for serverless functions. So when your container is a startup, it has to take all your code. It has, and especially regarding .NET functions, it has to set up your static components, the static variables and objects, and it basically builds your environment, right? And then it ensures that the runtime is all up and running, and then it finally does start your code, right? So as you can see, all the way from that process till here, you're experiencing cold start, and then you finally get your business logic up and running, and you finally start your business logic starts executing, right? And if you and as people may be familiar with it, like if you keep on pinging your function, it will always be in a warm state because you're still using it, so it won't be torn down. But if you don't use it for a certain period of for a certain amount of time, it will be torn down, and if you again invoke it, again you'll experience the cold start. Now that's the problem. You do not know when your container will actually be torn down. There's no way of gauging how long will it take of inactivity, how much inactivity will lead to your container being torn down and then leading to a cold start the next invocation. And the reason for this is because so much of the underlying architecture is abstracted away to the cloud vendor that you don't really know what's going on underneath. You just know that there's a function, and that's technically the concept. You just need to know about the function, and you just use it. I mean, you don't need to worry about the underlying architecture. But if you no longer need to worry about the underlying architecture, you no longer know what's going on in the underlying architecture. So you can't monitor, and that's a huge problem. And everybody's probably aware of this. Monitoring in serverless is just dreadful. Like it's hell. Azure has actually very good monitoring capabilities. I personally believe so. This is my personal opinion. I don't want to start off any lawsuits or anything against me, but my personal belief is Azure has really good monitoring capabilities as compared to AWS Amazon X-Ray, which is for Lambda monitoring. I believe Azure is better in this. But overall, when it comes to monitoring your functions as a service, it's hell, right? So at the end of the day, because we can't gauge when our containers will die, we can't expect when we will be experiencing cold starts, right? And this is just a short video that I recorded. So we were monitoring cold starts over here, and as you can see, cold starts are pretty random. Over here we have two cold starts. So these blue lines are cold starts. This is a very simple Lambda function, by the way. This is a simple hello world in .NET. Yeah. So we basically can't predict when we'll get a cold start. And as you can see, this reflects our invocation duration time, right? And that's a huge problem, especially when you have when you're trying to build business applications that are time sensitive, especially when you're building business applications that are customer facing and are sensitive to response, right? Let's say you're building a ticketing system and you have high traffic and people are all trying to build, buy a ticket. If somebody experiences a cold start, that customer is at a disadvantage as somebody who is being serviced by a function that is already warm. So that customer who is being serviced by a function that is experiencing cold start will probably not be able to purchase a ticket as fast as somebody who is being serviced by a function that is already warm. And all of a sudden you have bad customer experience and you have bad reviews, and at the end of the day your application is at a loss over here, right? And now imagine your competitor is using runtimes that isn't .NET and has an advantage of lower cold start durations. His user experience is just becomes better, right? And so anybody developing in .NET is at a disadvantage over here, right? So that's what cold starts can lead to. They're very scary. It's a very scary problem, and it's a problem that needs to be addressed, right? And the question then also becomes, okay, so everybody is experiencing cold starts. Java developers, Python developers, everybody is experiencing the cold start problem. But why is it a problem as profound for .NET developers or in the .NET environment, the .NET community? And so this is also, let's explore this. Let's get to the root of the problem. There are many theories around this. Many people say that, oh, it's because it's a statically typed language. So there's theoretically, so basically when you're setting up your container, during the container setup in that graph that we in the graph that we saw earlier of the function lifecycle, when we were visualizing the cold start and the warm invocation of the container, we saw because we have to set up our static variables and we have to load them into the application context, you experience longer cold start. But we don't see that, right? I mean, that theory is disproven because AWS in AWS, the Java runtime runs pretty well. In fact, sometimes it runs better than Python, right? So you don't really see that. So Java disproves that hypothesis, and well, then what could the reason be? Is it all just a conspiracy theory? Many people, I've had this discussion with a lot of people, and a lot of people say that, oh, it's because there's not a lot of the market for .NET in the serverless environment isn't as large as Java or Node.js. So obviously the engineers and the product managers and the evil product managers. I'm a product manager myself, by the way. And like we are always blamed for just thinking about the market value of a product, but I believe that's not really true. People say that, oh, obviously the product managers or whoever who made this decision, decide to focus more on the other runtimes than .NET. I don't believe that's true. The reason is because the cloud industry is a very competitive industry. It is a very competitive industry, and we're probably all aware of that, of the great cloud wars, right? The three great giants, Google, Amazon, and Microsoft. We have that, right? So in this competitive environment, we wouldn't expect people to lay off and become lazy about a certain feature, right? Because once you become lazy about it, your competitor is just going to go ahead of you, especially in this environment. So no, it's not because they're bad .NET compilers. I don't agree with that, and that's just a stupid theory, right? I believe, and again, going through, again, talking to a lot of people in the community and running a lot of experiments, I really believe it's just the jitting of assemblies, right? That really puts a lot of stress on the startup of ephemeral containers, right? It's because, and this is actually where the problem really lies, right? And if this is where the problem lies, and I've done a lot of experiments on this, which we will see later on. This is actually one of the major problems, right? And it really does depend on the number and size of your assembly files, right? And your libraries that you're using. At the end of the day, the DLL that you have at the end of the day really does matter. The size of that really does matter. And I mean, you would think that that is obviously, that is the obvious case, right? And but it's not obvious to a lot of people when they start off in this, right? So now we need to think about how we develop our .NET applications in the serverless environment, and how we facilitate this, how we go around this problem, So let's talk about the solutions now. How do we minimize cold start durations? And not only cold start durations, let's also talk about how do we minimize cold start frequencies? How do we always make sure that when a customer comes in, our function will be warm, right? So before we dive into the solutions, let's talk about the life cycle of a serverless function, right? So when you're building your function, you'll probably be authoring code, right? You'll then upload and create your function. You'll allocate resources to your function in your cloud environment, and then you'll perform monitoring and troubleshooting depending on your functions, right? So let's think about solutions throughout this entire process, all right? From each stage that you're developing your function, we have to constantly keep in mind that there is that evil cold start that's out there to catch us, right? And we need to figure out how we can reduce the possibilities of cold starts creeping up in each stage of our development, right? So if we start up with the most basic and the most simple solution, it's simply how we're writing our functions, right? Short story, just don't use static variables. Just don't use them. I mean, obviously, that's not the best solution, right? Static variables is one of the key components of your .NET environment, of any static type language, right? And in fact, there's also a trade-off over here. If you forget about using static and static type components, then one benefit that you're missing out on is the possibility to reduce invocation durations. So invocation durations are how long your function runs for when the container is warm, how long your business logic runs for. And the reason why people prefer static languages in the cloud, one of the reasons at least, is that when you have your static variables, once your container is set up, those static variables are stored in your context, right, in the lambda context, so that when you go back to it, when you invoke your function again, you already have those static variables ready for you. So it can lead to longer function executions, and it's not really an efficient solution. Like you won't really see much benefit in cold start durations, right? Another solution, a more effective solution, is considering the amount of resources that you provide to your function. So at the moment, with the basic plans of Azure and AWS, you can allocate, especially for AWS Lambdas, you can allocate a range of memories to your Lambda function, right? For those who are familiar with Lambda functions, they know about it, right? You can allocate, from 128 to 3008 MB of memory to your Lambda function, right? So tuning your dedicated memory does help. The more memory available for the container as it's starting up, the better cold start performance we see. And we'll see some experimentation in the next slide. But there is also a problem with this. The more resources you allocate to your function also means the higher chances of it being torn down in a shorter period of time, right? So now you have a trade-off over here. So you're trading off lower cold start durations for higher cold start frequencies. And you need to do some testing over there, and you need to do some tuning to realize where the best spot is. What is the best configuration, right? Because maybe maybe getting a cold start every time may not be that detrimental to your application as compared to high cold start durations. You know, if you can manage to have low cold start durations and have higher cold start frequencies. You know, and from experimentation, here I was comparing. You know, I ran this in AWS Lambda. I ran a basic .NET Core 2.1 function in AWS Lambda, and I provisioned different memory sizes. And as you can clearly see, the more memory we allocate to it, the lower cold start durations we experience. And this is great. This is great. But we also have to consider that the frequency of your cold starts then also increases, right? So that's the memory allocation solution, right? Another solution is while you're deploying your code, make use, you know, take advantage of the resources out there for you, to take advantage of the tools out there for you. And the .NET CLI is a wonderful tool that both Azure and AWS leverage to try to give you a better development experience, right? And basically what the .NET CLI does, especially when you're deploying your code to the vendor, is that it optimizes the libraries that you use, right? And what that means is that more optimized libraries means that there's less code to deal with for your container when starting up in the cold start phase of its life cycle, right? And there are also additional benefits such as templating, right? How many of you guys have used the .NET CLI to deploy a Lambda function for the Lambda developers? Right, there's, yeah, one person over there. That's great. Have you seen the benefits of it? Have you used the templating and other benefits of it? It's better? It's still hopeless. Oh my God. Yeah. Right. And the support is also hopeless. Yeah. Well, what can you do? Yeah. Yeah. Yeah, that is a problem. Yes. I mean, yeah, there's not a lot of support out there, right? There's not a lot of community help out there also. So I mean, that's why that was one of my motives to come and give this talk. You know. So yeah, I hope you learned something from this talk. Then you know, yeah. So you don't need to go to terrible support all the time. You know. Another great feature, and this is a very AWS Lambda oriented solution. So sorry for the Azure guys over there. You know, it's the usage of Lambda layers. So Lambda layers was introduced in AWS reInvent around 2018, right? And basically, what we see is that with Lambda layers, you can. So the way Lambda layers works is that you can, instead of having your libraries and your dependencies within your code and deployed within your code, and meaning that when your container starts up, it has this huge amount of dependencies to load. Instead of having that, you already put them as an external dependency within your serverless environment, within your functions environment, right? And layers can comprise of all the assemblies, right? And you can use the .NET CLI to build them. But the problem over there is that now, you know, working with your business logic locally becomes very difficult, because you don't have all the DLLs, the DLL files locally, right? So you know, it's difficult to use with static languages, especially because you need to have all the dependencies locally to compile and create the DLL files, right? And from what I know and from my experience, the AWS SAM framework supports the layers when being invoked locally. When you're testing locally with AWS SAM, it does support it. I am not really aware of any other framework that supports this. So yes, so now you know your development experience kind of deteriorates, but you know at the end of the day you will have better, you know, you will have a better performance for your application. And this is what we see with again with the experimentation. So without the layers, you know, I had some cold start durations of above 2.5, let's say, you know, somewhere around 2 seconds, and you can see it decreased with Lambda layers, right? Another great use of Lambda layers is you can take advantage of something of custom runtimes. Now, custom runtimes is so functions have their native runtimes that they support, and you can choose amongst them, right? But now with Lambda layers, you could also have custom runtimes. With custom runtimes, basically, you upload your runtime package as a Lambda layer, and you use the vendor's capabilities to execute your function. And there's a very great personality in this field. His name is Zach Charles. He's an engineer at Just Eat, and he makes use of custom runtimes to show how we can use something called Lambda native to get almost, to get extremely faster executions of our .NET functions, right? And what he does is that he used a library called CoreRT, which is a .NET Foundation project. It's an experimental library. It's not ready for production in its current state at the moment, right? And I really urge everybody to go check it out. It's a pretty cool library, right? And he used it. He configured it as a custom runtime in the AWS environment, and his results were amazing. He got like really low durations, cold start durations. And I really urge you guys to go check out his, if you want to take a picture of this. This is the piece that he writes, making .NET AWS Lambda functions start 10 times faster using Lambda native. Zach Charles, right? So he's a pretty cool guy, and I would like you guys should definitely go check him out, right? Finally, what we can also think of is keeping our containers warm. Now, this isn't to reduce cold start durations, but this is to reduce cold start frequencies, right? What does that mean? So, as I said before, like if your container keeps on experiencing activity, it will remain warm. It won't be torn down, right? Your container won't be torn down, and if your container isn't torn down, it will remain warm. And the way to keep your container warm is by constantly pinging it. Now, this seems like cheating. I personally don't like this solution. It's because it kind of misses the point of what serverless is meant to be. Again, in the beginning, I said that one of the great reasons why people are using serverless is because you have your resources when you need them, and when you don't need them, they're no longer there, and you don't need to pay for them. But if you constantly keep on pinging it just to be safe from cold start, then you are completely missing the point of serverless, right? It's not a very great solution, but it is a solution that works. I mean, you are reducing cold start frequencies, and therefore you no longer need to worry about cold start durations that much, right? And the way you do this is basically you set up scheduled triggers, small triggers that keep on pinging it, right? But that means that you will now periodically ping your function. And if you look at the serverless pricing model, you get charged per invocation. So each ping is an invocation. Now, this is where you need to really, monitor and really do some fine tuning with this solution, because if you ping it unnecessarily, you could all of a sudden experience unnecessary cost, right? Even though you're pinging it with just an empty invocation, so you won't have a very long duration, so you won't be charged a lot, but you are still being charged something, and you are still missing the point of serverless. So this is where you should do some fine tuning. You have to continuously iterate to know whether are you pinging it too much, or are you pinging it too little? Are you pinging it, if you're pinging it, in every 5 minutes and you're still experiencing cold starts, then maybe you're not pinging it enough. Maybe you're not doing enough to keep your container warm. Are you pinging it 5 times every 5 seconds? Then that's overkill, So this is where you really need to do the monitoring. And again, as I mentioned before, as we saw before, you do not know the period of time in which your container is going to stay up. So that's an added problem. On top of that, you can't really monitor your functions. That's another problem, right? So this is where you have to use there are a lot of third-party tools out there. So as I mentioned, I was working in Thunder. There's also another tool called Epsagon. A lot of people are probably familiar with Epsagon. How many people are familiar with Epsagon? They were a big competitor for us back in the day. Then there are other tools, Dashboard, and so there are a lot of third-party tools out there in the serverless environment for serverless monitoring that you can use, and you can use effectively to make sure that you're doing the right fine-tuning to make sure that you're not over pinging your containers to keep them more or under pinging them for and having no effect at the end, right? And this, yeah. So basically, you add this is just basically me showing how we can add a a schedule. It's pretty easy, and even though I'm not a big fan of triggers, it's a very easy and very quick fix, right? Let's look at what the experimental results in having these pings, and in trying to keep our containers warm. So we started off with a trigger every 5 minutes, right? So we were experiencing with warm-ups, with warm-up pings, we were experiencing around 77 percentages of cold starts, right? And they were 0.77% of cold starts, right, as compared to 19.41% of cold starts without the triggers, right? If once I started triggering it more frequently, right, what we start seeing is we saw those numbers reduce, right? So that was a win, right? So pinging it more was definitely a win. So again, as I said, this isn't the preferred solution, right? But it does work. So this is lower frequencies of cold start, not lower duration of cold starts. Remember, right? We also see current improvements. So we are seeing tiered jitting. We are seeing release of new .NET Core versions. We are seeing constant improvement of compilers, and we're seeing constant reduction of cold start durations, right? So we are seeing the industry moving towards improvements in this. And with these current improvements, these are the results that we're getting, right? So what we are seeing is that, so this is, if you compare the different, I don't know if everybody can see this, if we compare the different core versions, the .NET Core versions, obviously with .NET Core 1.0, we experienced like huge cold start durations, and this is across different memory allocations, right? Different memory sizes, right? And when .NET Core 3.0 came out, which is by default tiered compilation, we saw lower, and as you can see, this is the best cold start duration values that we are getting, right? There is a way that you can turn off the tiered compilation setting for .NET Core 3.0, and when you do that, this is what you're getting, and you're still getting improved cold start durations. But when we're talking about tiered compilation, so with tiered compilation, one of the disadvantages now is that because we aren't compiling all our code at once, we have to wait for that compilation throughout the running of our function, and that means longer invocation durations, right? We have to worry about longer invocation durations, and this is again one of the experiments that I noticed, right? So as we see, there is no one solution for this, right? We always have to think of throughout the function lifecycle, we always have to think of where do we how do we constantly think of improving our function logic, right? And you have to think of it while you're authoring your code. Should you consider static variables, static components? Should you use lambda layers? Keep on fine-tuning your functions. Use the .NET CLI. Do use it, and keep containers warm, right? And you keep on thinking of this as you're building your entire function, right? So these practices should be considered in all levels of building your serverless function, and and most importantly, trust in your cloud vendor, and expect improvements, because there is the cloud wars, so you should always expect improvements, right? In the end, I would just like to say that the future is serverless, and I truly believe in that, and .NET is to benefit from it, and when you finally do implement all of this, we can say that the cold never bothered me anymore. So yeah, that's a little Olaf from Frozen. So yes, so I think we have time for some questions. Yes.
Do you have the comparison between the code tier compilation and other languages?
And other languages? Actually, no, I don't have that, but that's something that would be very interesting for me to see, right? Yeah, maybe we should talk about that more afterwards. Yes.
Yeah, like if we use the custom runtime with the core runtime,
Uh-huh.
do you expect an issue like on your function instead of like running the normal .NET core runtime?
I mean, I think what I have experienced, I didn't use core RT personally, but I have used custom runtimes because a lot of times we use custom runtimes to have pre-configured monitoring capabilities in Lambda function, and sometimes what we notice is that invocation durations are affected in that. So yeah, you could have bad performing business applications at the end of the day. But if you check out Zach Charles' blog and his results, what he saw was that he didn't see that much of a problem when it came to performance, well, at least with core RT. Yes, see.
I actually have a couple of questions. The first question is with regards to, obviously, you have a call start function.
Right.
In certain circumstances, would it be a better architecture decision to actually have that bootstrapping while you're doing while you actually having doing some other actions? So you're browsing a website and you have that little dialog box, hey, click me to win something. Obviously, when the package is loading, that dialog box is being bootstrapped at the same time.
Right.
Would that obviously
Yeah.
to mitigate those kinds?
Yeah. So I think if I understood your question correctly, I think we were talking about how you structure your entire architecture, right? So now what we have over here, and this is again one of the great things when you're developing in serverless, you have to think about microservices. You have to think of separate functions, right? So one of the common mistakes, and this answer isn't only relevant to the .NET community; it's relevant to anybody building in serverless. One of the biggest problems when we're building serverless applications is that either we fragment too much or we don't fragment at all. So what does that mean? Like at the end of the day, if somebody doesn't split up his logic into separate functions or separate services, you could end up with one huge Lambda function, and that's just terrible when it comes to cold starts. Or the problem could be you fragment too much and you have all these small Lambda functions that all depend on each other, and now you have interdependency, and that just leads to bad performance also. So the goal over here is to fragment just enough to allow asynchronous operations. So like for example, something else is loading up, but the core component that, as you said, you have a dialog box spinning to load something that is experiencing cold start at the moment, but at least you have other components popping up on your web page, which so you do have some user interaction happening while another component is still loading. So that's really great, And there's a gentleman, Eric Johnson, who is an evangelist from AWS. He talks about the need for asynchronous syncing when building serverless functions. So if you are really interested in this, you could go check out his talk. It's called syncing asynchronously in serverless. Yes.
So another thing, I'm mainly from the Azure side of things,
right.
Azure functions.
Right. I'm so sorry that most of it. Yeah, it's just like at OpsGenie we are mostly building in AWS. Yeah.
No, that's totally fine. So
Yeah.
I'm not entirely sure with what the respective technology would be with regards to Lambda. But however, within within Azure, you have what we call the concepts of durable functions, which is basically your orchestrations.
Right.
So orchestrations would be, you could actually, you would have your microservices, your functions, which they're like in essence a subset of that orchestration.
Right.
So the orchestration would go out and go do different things. Does like my question is, does Lambda have that kind of capacity, and did you kind of test it with that orchestration?
Right. Lambda has similar capabilities, but no, I did not test it with that. And that's again, that's something that should be tested. And I do agree with you over there. Maybe later on I can. So I'm going to do a little write-up about this. I've already done some write-ups about this, but you had a great point, and I would definitely take your things into consideration in writing the follow-up to this, and like what, because I wrote when I wrote about my investigations. This was like almost a year back, and then we saw a lot of improvements. We saw .NET Core 3.0 coming out, right? So we saw these improvements, and like when I was preparing this talk, I had to like redo a lot of my experiments with the new improvements. So yes, but these are also some improvements that I should look into, and some more additional things that at least I should look into, at least before writing the next, the follow-up to this, right?
Sorry, I might be hijacking the floor here.
No, no.
Did you have a question?
Did anybody else have a question? Okay, well, let's go to the gentleman, and then we'll jump back to you. Yes.
There's not a managed runtime for .NET Core 3 yet, is there? On Lambda?
Native for in AWS.
Yeah, not managed.
Yes, there's a preview, I believe.
Preview, right?
Yeah.
So was the comparison you showed before?
No,
The preview?
no. So there was also a preview, and for this specifically, when I did this, I used a custom runtime, right? But I didn't expect it to be detrimental on the performance, on duration and stuff like that. And we didn't see that, right? If we look at the results.
Was the comparisons you showed, were they all using the same runtime, like the core RT or whatever, or
No. I was using a custom runtime for .NET Core 3.0, but I believe now, if I'm not mistaken, if I may be wrong, all right, because I haven't had time to look into the runtimes, the native runtime specifically for .NET Core versions in AWS Lambda, but I do believe that there should be a native runtime for .NET Core 3.0. We can check after this, yeah. But yeah, when I did this experiment before, I was using a custom runtime for to ensure .NET Core 3.0. Yeah. Right. Yeah.
So with regards to obviously having auto scaling, that would also affect cold start. So obviously certain techniques wouldn't apply there, since having a cold start, let's say you're pinging a specific function, but you have that function dynamically scaled. So when the need for that function to scale does increase,
Right.
obviously the underlying framework actually has to go and provision an additional machine, or
Yeah.
and be able to actually bootstrap that.
Right.
So, what in terms of scalability, how would you mitigate that?
Well, scalability, the scalability property of serverless functions actually occurs while the function is running itself. So it can happen both when, during cold starts, you don't really need to worry about scalability. I mean, because when it comes to cold start durations, it doesn't really, we haven't really seen much dependency on, we need these many machines or this many machine or whatnot, depending on the scale required. So you generally see a somewhat same amount of cold start durations. But when your container is already warm, then you may see some performance issues with having like 1,000 requests coming in all at once, whereas you were just having 100 requests. All of a sudden, you have 1,000 requests coming in the same second and the same millisecond. So then, obviously, the underlying architecture needs to like provision all these spin up all of these new containers. Over there, you may see longer durations, right? You may definitely see longer durations over there. And then also, depending on how your business logic is written, you may see some bottlenecks in your code or in your processing loops, maybe, let's say, So yeah, so that's how scalability affects duration times, cold start and during warm period. I hope that answers your question.
Yeah.
Yeah.
So I've got another question with
Right.
regards to so within Azure functions you have the ability to actually purchase capacity.
Right.
Obviously, I'm guessing that would be um, like you said, really functions is really used for that kind of approach. It's more of a pay as you go kind of approach. You don't really want to have to obviously buy dedicated compute. But for the people that really kind of that would be I'm guessing like a last ditch option there.
Right.
If they were to need that kind of performance.
Right. Sorry, I didn't understand. Like, you mean like provisioning more memory to your?
No, actually buying dedicated.
Oh, yes.
Purchasing dedicated compute.
Yes. So, I mean, I don't think that's so. Like in AWS Lambda, you have EC2 instances, right?
Yeah.
You have containers, and the pricing model over there, you actually can have dedicated resources over there, and then within that you can run. You can have you can use Firecracker, and you can actually run some virtualization within your dedicated instances. But I wouldn't say that that's not a really effective solution. So at the end of the day, you have a container. You already have a container, and you're already paying for that container. Why would you want to set up auto-scaling virtualization in that container? You just use your entire container if you've already paid for it, right? If you're right, does that answer your question? Yeah. Okay. Yeah. Are there any more questions? No? I will. Thank you so much for attending, and I hope my lack of .NET knowledge didn't, have if there are any issues with that. So, but again, this is a topic that really affected me, and I hope we can all go away learning something. So, thank you so much for coming. Thank you.